This lesson will cover the basic flying controls, their location on the aircraft, their operation and primary effects, and the various methods available to designers for making control of the aircraft easier and safer for the pilots, and ultimately, of course, safer and more comfortable for the passengers. Variations on the basic configurations will be covered in a subsequent lesson. The basic method of changing the attitude of an aircraft, that is, its position relative to the horizon, is by temporarily changing the camber of the airfoil of the wing, tailplane or fin, which will alter the lift it produces. The diagram shows the change in lift with changes in control surface position. The overall effect of a control movement will also depend on speed. An aircraft needs to be controllable about each of its three axes, which pass through the centre of gravity, or CG, which is conventionally portrayed by a circle with alternate black and white quarters. Basic controls will consist of flap-type sections incorporated into the trailing edges of the main flying surfaces, and positioned at the extremities furthest from the CG to give the greatest control movement. One axis runs vertically through the centre of gravity. This is the normal axis, movement about which is controlled by the rudder, the vertical control surface attached to the fin. The movement around the normal axis is called yaw and can be termed directional control. It is worth noting, however, that the rudder is not used to change direction by yawing the aircraft, but rather for preventing yaw, both in normal and asymmetric flight. This will be covered in more detail in a later lesson. The lateral axis passes through the CG running parallel to a line passing through the wingtips. And movement around this axis is called pitch. The control surfaces are the elevators, which move up and down together to give longitudinal control and are mounted on the trailing edge of the tailplane. The third axis is the longitudinal axis, which runs from nose to tail through the CG. Movement around this axis is called roll and is provided by the ailerons, which are mounted at or near the wingtips. They move in opposition. The downgoing aileron increases the lift on that wing, and the upgoing one decreases lift on the other, giving lateral control. These are the conventional three-axis basic control surfaces. In the following lesson, we shall look at variations on the basic types of control surfaces.